Okay, so we'll start this over again with the task number 1. Okay, so go to your editor, and above the editor window you can click new, and you've got a new editor window here. So here you save this window as, so go to your desktop and then your folder, and then you can rename your file as task01. So you have a file for writing the source code for the task 1. Okay, so this task will be about scientific computing. Okay, so what we will do here for this task is we're trying to use Python to calculate a physical quantity. The bore radius. Okay, so to be so essentially, we want to reproduce this equation of calculating the bore radius, or A0. So in this equation, you can see many of the physical quantities: the permittivity, the Planck constant, the mass of electron, and the electron charge. Okay. So the first thing that I will do here, I will need to import the library called NumPy. So NumPy is the default choice for me. It has many mathematical operators, and it can work with array operators. So this is very convenient library. This is my first choice for importing the library. So import NumPy as NP over here. That means from now on, every time that we mention about NumPy, or every time that we want to use the command from NumPy, you can refer the NumPy library as the NP. Okay, so the next one, we want to specify the values for the parameters. So I would say setting up parameters, okay, or the constants. So we can start with defining the epsilon 0 here. So you can create a variable called epsilon 0, and you can input the value into on the right hand side of this equation. So the value for the epsilon 0 is 8.85 times 10 to the minus 12. So how to type the 10 to the minus 12? You just type e minus 12. So this means times 10 to the minus 12. And then the hash bar, or the Planck constant, what we do is 6.63 times 10 to the minus 34 and divided by 2 pi. Okay, so 2 pi, you can write down 2 pi like this. So it's 2 times, so the pi value, you can get the pi value from NumPy. So what we do here is np dot pi. So this will give you the pi value. Yeah. And then the other two quantities is the mass of the electron and the charge of the electron. So the mass of the electron, so it is 9.11 times 10 to the minus 31. The charge of the electron, it is 1.6 times 10 to the minus 19. Okay, so the next step now, we are going to use these parameters to calculate the A0, or the bore radius. Okay, so we just make a comment here. So the bore radius. Okay, so how to make the comment in Python? Yeah, you can you can type down the 3 quotes sign, and you want to close this by the 3 quote signs. And the comment of this type, you can do it in many of the lines. But another type of comments that you can make that the program will not recognize is you can use the hash sign, and you can type any comment after the hash sign. But for the hash sign, you want to do in the same line that you have the hash. Okay, so otherwise you will have you get something like this, some error, undefined name. The program will not know this, but here the program will ignore the any of the words that is after the hash. Okay, and if you ignore the words or any comments in between the three quote signs. Okay. Okay, so for calculating the ball radius, so we will just reproduce the equations. So A0 is 4 pi epsilon h bar square. So it's 4 times pi is np dot pi times the epsilon 0. You can also copy this to here, and h bar and how to type square. Yeah, the power in Python, we use this one. We use the double star as a power, so it's 4 pi epsilon h bar square. So you type down the star 2. Okay, and in the denominator, you have the me, the mass electron, and the electron charge square. So we need the me and times by the e square. Okay, and here is a square. Okay, so now if you want the program to show the A0, okay, so you can simply type print A0. So in the Python 3, you might need to type the bracket at the A0. Okay, so now you can click run. So here is what you get for the ball radius. So this is the correct ball radius. Okay, so the other way around to print this your value in the more elegant way is you can write a quotation sign here, and you can send the message to the reader like the ball radius is, okay, and then I will type something that might looks a bit weird here is percent 8.3 e. Okay, so this percent 8.3 e, this is the format. Okay, so we we made a note for you here. So print the result out in a formatted way. Okay, so for example here percent 8.3 e. Okay, so 8, so the 8 means it would mean you require 8 digits, okay, for printing your result, and the number 3 or the dot 3 means you need 3 decimal numbers, yeah, and then E here means you want a scientific number. Okay, so you have the 2 more file type here, that 2 more variable type here that you can print out. So if you do the percent like 8.3, so you can also do like 7.4, or it can be anything. And if you type down the F, so this will mean you printing a float or just a number with decimal number. Yeah. So the difference between the float and the scientific number is, for the scientific number you always write your numbers and times by times by the order of magnitude, or something like 10 to the minus 11. But if it's the float, you just have a number like this. Okay, so here we are printing the ball radius as the scientific number. Yeah. So what you need after the quote sign is you need a percent sign, and then followed by your variable. Okay. So so let's have a look at what the program will print for you. Yeah. Okay. So here we tell the program to print this message: ball radius is. Okay. So it does it up until this point: ball radius is, and then after that it followed by the formatted number. So this 8.3, it is you are using the 8 digits. So 1, 2, 3, 4, 5, 6, 7, 8. So this is actually this is doing 9 because this is doing 9 because it required 9, but you specify like the less number. But if you do it 10 here, it will give you one more space. Yeah. So if you count it here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 digits. Yeah. And 0.3 here is 3 decimal numbers. Yeah. And the E here, it means you're printing a scientific number. Yeah, like this. You're printing the order of magnitude. For example, if you try something else, like if you try 12.6 and run, it will provide you 6 digits number, 6 decimal number, and 12 digits here. But what if you change this to 12.6F? Okay. So this will give you just the number. So actually, this number is very small. It's smaller than 6 decimal number. So it will just give you 0. So this might not be the best choice to do for this case. So we change this back to E, and here you get the number of ball radius. So that's the end of the task 1.